This is the first video on the section on bonding, and it is obviously on what are called Lewis dot structures. Now, Lewis dot structures are a pictorial method that we use to keep track of the valence electrons. Keeping track of valence electrons is important in bonding because in chemistry, all bonding occurs at the valence electron level. What we're going to do is use dots to represent valence electrons, and that's where the last part of the name comes from, dot structure. Lewis was a very famous chemist, and this was his idea. And if the dots represent the valence electrons, then the symbol of the element represents both the nucleus and the non-valence electrons. It's pretty simple to do. I'll describe it, then show you. After you write down the symbol for the element, you're going to think of it as having four quadrants: top, bottom, left, and right. You're going to start to add a dot or a valence electron into each of the quadrants, one quadrant at a time, and you cannot double up on a quadrant until each quadrant has a dot. This is not electron configuration rules. We're not going to follow those for electron dot structures. And the rules don't apply to hydrogen or helium, but once you see how this works, that becomes very obvious. So let's go to period 2. We'll go across the period, so we'll start with lithium and end with neon. And we look at lithium, and we write down the symbol. Since lithium is in the first tall column, it has one valence electron, so we put a dot in one of the quadrants. It doesn't matter which quadrant you do it to. I tend to put my first one here. Then we go to beryllium. Beryllium has two valence electrons. It's in the second tall group, so there should be one dot in each of two different quadrants. Go to boron with three valence electrons, then the dots should be in three of the four quadrants. Carbon has four valence electrons, so one dot into each quadrant. Now we come to nitrogen. Nitrogen has five valence electrons, so we put one dot into each of the quadrants, and that's four valence electrons. Now we can double up, and so we have one pair and three singletons. Oxygen has six valence electrons, and that works out to be two pairs and two singletons. Fluorine has seven valence electrons, so it looks like this. And neon, being a noble gas, has 8 valence electrons of 4 pairs, and so it looks like this. If you go down to period 3, this becomes a very easily visualized periodic trend. That's all there is to Lewis dot structures. We'll be using these dot structures to show how electrons are either transferred or shared to allow for various types of bonding. So for a quick review, Lewis dot structures are just a visual way of tracking valence electrons. Make sure you put one dot in each quadrant before doubling up, and we do not follow the electron configuration rules. In the upcoming lectures, we'll be using Lewis dot diagrams to help us figure out the bonding.